All right, we're looking at today strengthening literacy and numeracy through a workplace task analysis, and the idea is to link that in with learner success. I thought I'd just begin with this karakia. I really like this karakia because it is very much about life being quite challenging. We all have challenges in life, and out of these challenges we get stronger as well. So whakataka te hau ki te oru, whakataka te hau ki te tonga, kai mā kina ki uta, kai mā taratara ki tai, ihi a ki ana, ti a te kora. He tio, he huka, he hohu, tai hei Māori ora. It's good, you know, I looked into this karakia. Very interesting to do with the frosts, being cold, the chilliness, and just nature and how we can rise to the occasion. So in that spirit, let me give you an overview of today's session. I thought that seeing as you're all such willing participants out there, we'd just do a micro introduction on proportional reasoning, and you'll see why, because the task we're going to look at is quite a complex one. So a little bit of a buffer on proportional reasoning will be good. And then we're going to analyze a task, and then we're going to look at what the intervention was, what the teaching and learning was around that task, and then reflect on that process as well. So that's what we're looking at in this session. Are you ready? You don't have to be super good at numeracy for this, but I want to show you something that pops into the school curriculum when learners are around 11 or 12. So here it is. Just take a moment and have a go at this fun assessment question. It takes 10 balls of wool to make 15 beanies. How many balls of wool does it take to make 6 beanies? Just have a little play with that for a moment. Chuck it in the chat if you think you've got it. See how you go. Well, yeah, you guys putting that into the chat as 4, wonderful. You are well onto it. For every person that puts it into the chat, there'll be another person that's like, what is going on here? I can't quite make sense of this. This task, I actually did this in a study with adult tutors. And so imagine the poor adult tutors, I sat down and I would slide this task over to them, you know, if it takes 10 balls of wool, etc. And it seems to fry people's brains. And so this is what's called proportional reasoning. It's really hard to work out because you're trying to sort of halve 10 and halve 15, and it's not an equal number and all of those sorts of things. So Amy's just said, can you enable mics and cameras? Yes, please, Amy, that'd be fantastic. And just if you've got something to say, just pop up your hand and I'll come to you. So this task here is what's called a doorway task. So learners should be able to solve this before they go to high school, which is a little bit humbling for us in the adult sector. So the way that you'd work it out is it's 10 to 15, you know, 10 balls of wool for 15 beanies. And then what you're supposed to do is you're supposed to be able to identify that that's 2/3. You know, how many 5s are in 10? 2. How many 5s are in 15? 3. So that's 2 to 3. And then you could double the 2 to 4 and 6. Complex, right? If you don't know how to do that, or if that's new to you, that's really hard. And it turns out that that's really hard for everybody, which is interesting considering that in the curriculum, in the New Zealand curriculum, most people are meant to be getting that at around their last year of intermediate. So Lehman is one of sort of the key proportional reasoning researchers in the world, and she estimates that sort of half of the adult population really not only have difficulties with that, but are unable to solve that. And what's interesting, in more recent materials that she's done, she's actually said she thinks that probably 90% of the adult population have problems with that. And if you're familiar with the PAC and all of those sort of literacy and numeracy things, you'll find that it's very true in New Zealand. New Zealand has an adult numeracy issue, and this is one of the big issues. This is called proportional reasoning, and essentially you need proportional reasoning for a whole lot of tasks. Just for example, in agriculture or horticulture, you need it for mixing up sprays. You need it in building. For example, this top one here is building mix. This is for making cement and mortar. You know, it's a ratio of a certain amount of buckets of builder's mix to cement. This bottom one here is interesting. That's when you build a ramp, a wheelchair ramp into a building, and it's a ratio of, for every meter high it is, it needs to be 12 meters long. So, what if it was 0.7 high? How would you work out how long it is and so on? So it turns out proportional reasoning is essential for workplace tasks. And it acts as a bit of a doorway. So it's essential for mathematics. You need to have proportional reasoning to understand algebra, calculus, all of these further things, even statistics. And you also need it to complete tasks. And so what we discover in New Zealand is that proportional reasoning is a major barrier to success with numbers, both in the workplace, in apprenticeships, and also just in normal people's study. And unfortunately, when you're learning mathematics, it's one of those things, if you don't understand it initially and the curriculum moves on, then you don't really catch up. So that's what proportional reasoning is. And I thought I'd just show you a quick little way to work it out before we go on. Proportional reasoning is all about seeing invisible numbers. And seeing invisible numbers is actually like a superpower. So I'm going to give you the secret sauce on how to do this. Let me just show you something. Proportional reasoning is seeing the numbers that are not written on the screen. So for example, on the screen right now, you have a 5 and a 10. And I just want you to think to yourself, what's the relationship between those two numbers, a 5 and a 10? Just think, how are those two numbers connected? If we were to put on our glasses and see the invisible numbers, we would see that 5 is half of 10. And you could also double 5, right? So the two invisible numbers are half and double. And so that would mean if we had then, 10 and 20, it would be the same thing. That relationship between those two numbers doesn't change, but it's not written on the page. So here's another one, 3 and 9. What are the invisible numbers that connect those two numbers? Let's put on our special glasses and have a look. 3 times 3 is 9. So 9 is 3 times bigger than 3. And 3 is 1/3 of 9. And if you're normal, who's normal? But if you were normal, the 1/3 is a little bit harder. Most people get, 3 times 3 is 9. But the 1/3, you kind of got to think about it in reverse. Last one, have a go at this. 12 and 3, what's the secret relationship? Put on our glasses. Times 4, 3 times 4 is 12, and 3 is 1/4 of 12. That's it. That's the whole proportional reasoning thing. Once you can kind of learn to see the invisible numbers, you can understand proportional reasoning, and you can use it in cooking. You can use it when you're mixing cement, all of these sorts of things. So that's the skill that really gives a lot of adults in New Zealand real difficulties with not only learning study of numeracy, but also workplace tasks and so on. And for those of you who are familiar with the adult learning progressions, that task, working out, the 10 balls of wool, sits at step 6. And so it's really high. It's the highest rate or highest step on the adult learning progressions. And this is it. An adult at this step will use multiplication and division strategies to solve problems that involve proportions, ratios, and rates. And to be honest with you, that invisible number thing is the solution to working out rates, proportions, ratios, and so on. So that is what we consider proportional reasoning. 90% that's an estimate of the population struggles with that, the adult population, and it's also essential for a whole lot of things. So that's the backdrop to what we're going to have a look at. Just in terms of learner success, of making sure that learners that come into the tertiary sector, into your courses, that they have success. What we want to do with both learner success and literacy and numeracy is we want to use data to identify where learners are having difficulties and then put support into that area, right? That's the idea. And then once we've got the support in place, really we want to iterate that, make that better and better and better as we put more learners through it so that it's highly successful. So in my mind, the literacy and numeracy infrastructure that we're going to have a look at fits underneath learner success. It's a subcomponent of learner success. For those of you who are not familiar with literacy and numeracy, you might be surprised to know that the proportional reasoning stuff we just looked at, for example, continues to give learners difficulties at university in terms of statistics, all the way through high school down into primary school. So It's not like it's a thing that only hits learners at foundation level learning. It's all through the system. Okay, this is the framework for the literacy and numeracy framework. Oh, some people talking in the background. Just get you to mute your microphone. Thank you. This is the framework for analysing things within literacy and numeracy. So there's 3 parts to this framework: know the demands, know the learner, and know what to do. Now, knowing the demands is the one that usually people are not so familiar with. Knowing the demands is having a look at your course or the vocation, the jobs that you're training learners for, and having a look at what the literacy and numeracy demands of that particular job are, or that course. So just to, for example, to read the study materials on a course will mean that learners need a particular level of reading. But if they're going to go and be mechanics, for example, then they're going to need particular measurement skills. And in hospitality, they're going to need particular verbal communication skills. Each industry will have its own little set, unique set of literacy and numeracy demands, and you would map those out. So you would work out what those are. Knowing the learner, you would use assessments such as the LNAAT, for example, to work out where your learners are in relation to those demands. And then the know what to do is the fun part. That's where you put in teaching and learning strategies, support mechanisms, and so on to support those learners once you've identified that they need help in a particular area. Very similar to learner success. Learner success has different criteria. This is really looking at its own sub-criteria: reading, writing, numeracy, speaking and listening, and so on. So let me show you what a task analysis is. A task analysis is where you would go into, for example, here's Willow, and Willow is working on a farm, and essentially a literacy and numeracy person will go around with a clipboard and look at all of the kinds of tasks that they do, and we'll want to identify the tasks that are causing all learners or most learners real difficulties. For example, it might be measuring out drench, as in this example, reading that in mils and so on, and then mapping out what literacy and numeracy is needed to complete that task. Once you've done that, what you end up with is a whole list. So you're going through and you're trying to find, for example, in numeracy, all of the things that a farm worker would do in terms of numeracy, or an accountant would do, or whatever it is, and so on. You have a huge list and you want to be able to prioritize certain tasks. And so this is a pretty good framework for prioritizing tasks. So a lot of people think, supporting people with literacy and numeracy, it's just too big to be able to realistically do. And they're often thinking, am I trying to do what school did for this learner? You're not trying to do what school did. You're trying to analyze a particular task and build the skills for that task. And here's a good model. You look at the frequency, you look at how often learners need to do this task, you look at how complex it is, and you look at the expense or the cost of this task. And I'll just give you an example. If you have a look at painting, this is studying to be a painter, you might be doing an apprenticeship, and you also, what are the skills needed for the job? Here's one of the skills that is a nightmare for painters, particularly if they have low numeracy skills. But what you have to do is you have to measure the area to be painted in square areas. So you have to work out a room, subtract the windows, the whole thing, put it all together. And then you have to go to the paint shop and you have to work out the coverage rate. So each paint on the back will tell you how many litres it takes to cover so many square metres. So 1 litre might cover 7 square metres of your primer. And then the next one might cover, 1 litre might cover 4 square metres, or usually it's a bit more than that. So there's a lot going on there. So there's a bit of division. There's actually a little bit of proportional reasoning because it's given in terms of a ratio, 1 litre to 7 square metres and so on. If we map this task, we go, how difficult is this task? Well, it's a 4. It's difficult. It's at step 6 of the adult learning progressions. How frequently is it completed? Well, it's not done every day, but it is done every job. So every job you have to quote and then buy the paint. And if you don't get the right amount of paint, then the color codes don't match. You wind up in a whole mess. How important is it? It's really important. So it's important for quoting. It's important for doing a good job. Another task that painters have to do sometimes if they're working for somebody is record the kilometers in the van. This is what we did. We did a study of, in all different industries of what the numeracy needs were. So how difficult is the task? It's easy. You just copy down what's on the speedo, you know, easy. How frequently is it done? Once a month, so not very often. How important is it? It's a 2, really. If you were to miss it, the world wouldn't end. We'd just do it at the next month, you know, and so on, and divide it. So no big deal. So that is not going to be a task we're going to look at. That is a score of 4. The score of the paint, you know, working out the paint, is an 11. So we can prioritize the paint. Now, these tasks, when we look at how important they are, they have costs associated with them. So there's the cost of rework, there's the cost of repairing, replacing equipment, all of those things. I'm going to give you some examples of this, but these are things that usually cost a lot in terms of economics, but also the human cost is another thing that's quite big. Loss of confidence is something that we found. So basically learners will make a mistake, you can imagine, and then they lose their confidence and they stop doing that task again, particularly learners with lower literacy and numeracy. So in the painting, you might mess up the paint order, so you don't order enough paint is worse than ordering too much. It knocks your confidence. So what you do is you just ask somebody else to do that task for you. So you don't learn that task, you know, unless you're sort of dragged kicking and screaming back into it. It leads to course dropout, and it leads to lack of motivation, of course, and depression as well. We did a study around dyscalculia. Some of you will have read it a couple of years ago. Workplace, you know, depression, it's tough when you're trying to make your way in a workplace amongst your colleagues and you're making mistakes on things like that. So the human cost is really high. So here's an example of us analyzing a task and then putting in some teaching and learning around it as well. So one of the tasks that we found was to do with agriculture, horticulture courses, and also landscaping, which was where learners were mixing petrol. When you have a 2-stroke motor, mixing the petrol and the oil incorrectly, and it was breaking the equipment. So just for example, I know that 10 brand new Stihl chainsaws all broke on the one day due to the fuel mix being put together wrong. We went out, we looked across the sector whether this was a big issue. Here's the landscaper. The amount of money I spend buying or fixing equipment is ridiculous. Last year, we went through 2 post-hole borers in 1 month for that exact reason. Post-hole borers, chainsaws, weed whackers, you name it, they all function on this 2-stroke oil that you have to mix up. So when we do an analysis, how difficult it is it? It's a 4 for sure. It's proportional reasoning, just like we looked at the beginning. How frequently is it completed? Sometimes it's daily. Usually if it's done daily, what we found was one person would take care of it. And oftentimes they would be told exactly how much oil to put into a particular container. But of course, if there were containers of different sizes and so on, that's when things would struggle. So whenever somebody had to work it out new for themselves. How important is it? Really important. You're talking about equipment being lost. So I thought I'd ask you and throw it into the chat. Imagine you've just bought a brand new post-hole borer and it's 50 to 1. What does that mean, 50 to 1 petrol and oil mix? You're going to put a little bit of oil in your petrol, right, before you put it in. So does 50 to 1 mean 50 mil of oil to 1 litre of petrol? Or does it mean 1 mil of oil to 50 mils of petrol? If you get it wrong, you destroy your brand new post-hole borer. What do you think? Chuck it in the chat. I'd love to know what you think. I love it that we've got different answers. Good, good. I'm guessing A, B, 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 A, B, B, B. A lot of people saying B. Very brave putting that in there. Good on you. Okay, so the answer is B. Let me just say that most people get this wrong, and I'll show you some funny things very soon. Most people get it wrong, but what it means is 1 mil of oil to 50 mils of petrol. It doesn't mean 50 mil to 1 litre of petrol, even though most people think A. Most people I do this with think A. And there's a reason why you think A. And it's actually, you know, we could say this, the people who picked A, you're actually super intelligent. And what you've done is you've overgeneralized something. So there's no shame in it, trust me. It's a bit like when a child, they go through a stage where they're trying to work out past verbs and they say things like, I catched the ball instead of I caught the ball. If your child says, I catched the ball, that means they've generalized all the other rules and they've just applied it to this one thing where there's a difference, high sign of intelligence. It's a normal thing to go through. Exactly the same with this, and I'll show you why. Actually, just before I show you why, let me just explain what's going on. If you interpret this as 50 ml of oil to 1 litre of petrol, you end up adding too much oil. And so you probably won't wreck it. The motor won't start, it'll lack power, and you'll shorten the lifespan of it. But basically, you've added too much oil, so you've sort of diluted the petrol. So the petrol's not cranking how it should be. However, most two-stroke engines nowadays have 25 to 1. If you misinterpret 25 to 1 as 25 mils to 1 litre, you end up adding too little oil. So you'll put in 25 mils instead of the 40 mils that are required, and you will destroy your motor. So the Stihl chainsaws, they're 25 to 1, kaput, they're gone. So they keep working and then they'll just suddenly die on you and you'll be like, gee, what's going on? And then you either have to get the motor reconditioned or buy a new Stihl chainsaw. So it's high risk, right? It's high risk and it's different. 50 to 1, 25 to 1, and so on. So that's the problem. We have all of these young learners occasionally mixing petrol and oil mixes and wrecking the equipment. We have lots of people who bring home their brand new Stihl weed whacker, put in the wrong amount, and they wreck that, or post-hole borers and so on. So let's do a deep dive. This is what we do. We've identified the issue, and now what we want to do is understand it and teach learners how to do it properly. So we go to the adult learning progressions. This is, if you're not familiar with these are a framework for how people learn numeracy and literacy. And what we want to do is we want to identify the learning trajectory. And what that means is we want to know, for somebody to get at step 6, to be able to do this task, to mix the petrol and oil properly and understand ratios, where do they start? Like, what, obviously they have to know how to count, add, multiply. What is this sort of the step-by-step process by which somebody comes to be able to do that? Once we've got that, then we can begin to teach those things. And we also want to investigate why learners make that error. Like, why do people make that mistake? Think that it's for 1 litre. And we really want to map out the 3 most common mistakes. If you were to do this one thing, look at where learners were having difficulties or making mistakes, and then just look at why they make the mistakes, you'll quickly find it's either 1, 2, or maybe 3 things. Most people make very predictable conceptual errors. So, in the adult learning progressions, here it is here. This is what we want. We want people to be at step 6. We want them to use multiplication and division strategies to solve problems that involve proportions, ratios, and rates. Now, you don't have to read all of this, but what this does is it shows you all of the skills that a person needs to be able to do this. It gives you examples of it. So it's really good because what this shows you is what the skills are that are needed to be able to do this task. And this way, you can begin to assess learners and work out where they're at. It gives you a learning trajectory. So here is the entire proportional reasoning pathway. So you might not be able to read this, but at step 2, it says find a fraction of a set by using equal sharing. So this might be like you have 6 cans of Coke and you're going to share them between 2 people. So you equally share them. You go 1, 1, 2, 2, 3, until you get 6 on each side. That would be the starting point for somebody on this learning journey, right up to being at the end, being able to mix petrol and oil. So these are very important. They show you the pathway, the ladder that has to be climbed to get there. And this makes sense of the LNAAT assessment because here we have Martin, and we can see that Martin is at step 3 in his numeracy. So that means that Martin isn't sharing out the cans of Coke. He already knows how to do that. He's at step 3. He knows how to use multiplication and division facts to find a fraction of a whole number. So he can start at step 3 on that learning trajectory. So we know what skills he needs. We've assessed him and we know where he's at. And now we can begin to put together that plan. When we go and have a look at why people make this mistake, let me just take you into a deep dive on what this is. So you have a look at the research. It turns out there are 2 types of ratios. There's actually a couple, but actually more like 3 or 4, but 2 main types. One is called a commensurate ratio, where both units are the same. So when we have a look at a petrol and oil one, 50-to-1 means 50 milliliters of petrol to 1 milliliter of oil. It doesn't matter what order those two numbers are in. They're the same unit. What happens is there are non-commensurate ratios out there in the world. For example, kilometers per hour. This is where you have kilometers and hours traveled. It takes an hour to travel this many kilometers. They're different units. And this is what people are used to. So 1 egg per cup of flour. Most of the time that you see a ratio, they're non-commensurate. So they're different things. So what that does is it teaches learners that they're different things. 1 liter, different unit to milliliters and so on. So it's normal. You've been taught your whole life that these are different things for convenience, and suddenly you come across this one, and so it operates in a different way. So there are different things. So that's the main reason. And if you think about that, you can solve this problem just by making people aware of it very quickly. Let me show you something that I think is quite funny. I put microphones in classrooms and I studied a lesson on this. So I thought I would show you some of the feedback. In this lesson, the tutor wrote on the whiteboard 25-to-1. And then he said, what I want us to think about today is what that word ratio means. What's that mean? And so I'll get you guys to pair up. Now, just think to yourself, what would you think to yourself if you saw 25-to-1? You might go 25 mils to 1 liter, because that's what we've sort of discovered. Or you might go 25 mil to 1 of petrol to 1 mil of oil. Anyway, here's Harley. Straight away, Harley says, F-U-C-K. I don't know what it means. Pushes his chair away from the desk, indicating non-participation. So I'm watching Harley. We're catching his thing. So immediately, he doesn't really want to engage. He doesn't know what it means. But then he has a go at it. 25 mils to 1 liter. And so you can see there in that top line that he's automatically got that wrong thinking, right? And then the tutor sees that he's being a little bit disruptive in class and says, because in a minute you're going to have to explain to the class what your little groups come up with, eh? So the tutor is trying to, get Harley to get with the system. And then Harley says, that's what we came up with, 25 mils to a liter. If it's wrong, then God bless my soul. And yeah, you can see it's just going to be an interesting lesson. Here's what he says next after a little while of thinking about it. F-U-C-K, I'm shite at numbers. It's 25 mils to 1 liter. He doubles down, 25 mils to 1 liter. That's what I just said. And then a little later, he says, shite with numbers, but not when it comes to money, mate. And so what I did is I looked at these little conversations that were happening around the room. There's another group that I haven't included, and they get right into it, and they sort of work it out just by talking to each other and so on. But you can see here from Harley that Harley thinks it's 25 mils to 1 liter. And so when I say to you, go and find out why people make mistakes, it's really good. It's really simple sometimes. You just let them talk and they'll reveal to you, and then you can fix it very quickly. Now that we know what skills are needed, we need step 6 skills, and we know why people make mistakes, we can use the learning progression framework to design an intervention. So I'm going to show you what we did with these groups and how successful it was. When you're putting this together, usually you go to a framework. The learning progressions are as good as any other framework. They're all research-based, so they're all very similar. I personally go to the research. So now that AI can do this for you, you could go to Chat, Claude, whatever it is, and say, hey, give me some research on how people would learn to mix petrol and oil. How do people learn about ratios, proportional reasoning, and so on? You could ask Chat for lessons at each step on the learning progressions. It knows all of that. So it's really like sitting down for an hour and mapping something out, doing some work on this, and you'll have it. You'll have a nice progression, and the idea is to put it in order from easy to more complex. These books that are here and the learning progressions in general have a framework, that people develop skills on their learning trajectory as they advance. These books contain a table that exactly mirrors the learning progressions, except instead of having a description in here of what the skills are, it gives you an activity that builds those skills. So this is really, really useful. So we can see that ratios here are at step 4. And you'll see there's no activities for the first 3. That's because you need all of these other skills before you get here. So that would be your focus. And then suddenly we've got step 4 activities, ratios 1, fractions of numbers, and those will give you the activities that you can then work on to develop the skill in learners. So let me just show you what we put together for learners. This is highly successful. This was around 4 20-minute lessons. I think we got it down to 3 20-minute lessons, and almost everybody can come to learn how to mix petrol and oil following this process. So I'll just show you very quickly. We would ask learners, first of all, what does 2 to 1 mean? And then we would let them talk. And you kind of saw Harley's response. We would set it up a little bit nicer than that. What does 2 to 1 mean? And so just have a think for yourself. What does 2 to 1 mean? You know, what does that mean to you? We handed out Post-its of 2 different colors to the groups. 2 to 1, we would just say 2 to 1 means for every 2 blue Post-its, you need 1 golden Post-it. That was it. So for every 2 of these, you need 1 of these. And then you would get people to come up with examples. What's something else 2 to 1? For every, I think it was something like, at the time I was working at a particular organization, for every 2 learners, they needed 1 tutor. It was something like this when they went on an away trip. All of those things, you know, you're getting people to come up with things 2 to 1. This was all part of lesson 1. And so that was a big part of lesson 1, just letting people know that 2 to 1 means 2 for every 1. For every 2 blue Post-its, we need one white Post-it, and so on. And then we would just do this. Okay, 3 to 4, you've got 3 blue Post-its on this side. How many golden Post-its are going to go on the other side? Just see if you can work it out for yourself. It's 4. It's going to be 4 on that side. For every 3 blue ones, we have 4 golden ones. Easy, right? So we're not trying to trick people. We're not trying to make it complex. Just presenting this. All right, on a ratio of 2 to 3, we have 2 blue ones. How many golden ones are we going to need? 3. And we might, depending on the group, just continue that for 10 to 15 minutes and stop. And everybody goes, oh, that's really easy. That's too easy. You know, and that's what you want. You want people saying this is too easy. If they're totally cranking it, then we might do something like this. If we have 4 golden ones on this side, and it's a 1 to 4, how many blue ones are we going to need? 1, you know. And then the next step would be something like this. This time it's a ratio of 2 to 1, but now we have 4 blue Post-its. So how many golden Post-its are we going to need on the other side to make this work? So this is a next conceptual step, you know. It's like, oh, okay, what's it going to be? Well, it's 2, because for every 2 blue ones, we need 1 golden one. So for those 2, we need 1. For those 2, we need 1. And that's it. And we want them to develop that language. For every 2, 1. For every 2, 1. If you wanted to, you could do the invisible number thing here. You could go, there are 4 blue on that side, and that number is 2. So what's the relationship between 2 and 4? It's double. So we double the 1 to the 2. That's the invisible number part of it. Usually we leave that out. That comes at the end, or maybe we don't even go there. And then when they're having success, we shift to these little cubes, and I'll tell you why we shifted these cubes in a moment. Same thing, 2 to 1. And if we have 4 on this side, then we're going to have 2 on that side. That's how that works. And then the whole lessons might just be like that. 3 to 1, you know, how many are going to be on this side? How many green cubes are there going to be? Well, for every 3, there'll be 1. There's 9, so 3, you know. We want them to be having success in finding this easy. And it turns out that what you've just seen is kind of the conceptual model you need to be successful. Once you've got this, the rest of it falls into place. Finally, we would introduce 25 blue ones on this side, 1 on this side, you know, and you can see where we're going with this, because that 25, those little cubes, that's 25 mils of petrol, and that's 1 mil of oil. So that's how that's going to work, you know. So that would be a lesson, and that would be, well, that would, you're actually seeing 2, maybe 3 lessons there, depending. Each lesson around, it says half an hour, but way shorter than half an hour. Now, let me just show you something interesting. The reason we use cubes is because water volume is always measured in these little ice cubes. So 1 milliliter is actually 1 cubic centimeter. So a good way to think about water is to think of it frozen into little cubes about the size of a dice, right? So you look at that water and that might be like 250 mils. What does that mean? That actually means 250 little ice cubes piled on top of each other. It's a great little visual trick if you're having difficulties with volume. This is all at step 6, right? So it turns out that's how that works. Water, petrol, oil is measured as a little cube. And so you can actually buy this really cool thing where you freeze water and you get the cubes and you can pile the cubes up. That is another major kind of conceptual leap for learners. So the next lesson would be, hey, there are 1,000 milliliters. That's 1,000 of these little cubes. That's what 1 liter is. So 1 liter equals 1,000 of these little cubes. That's another kind of conceptual part. And then the final lesson would be, all right, so we've got all these little blue cubes of petrol and cubes of oil. How many 25s are there going to be in 1,000? Because for each one of those 25s, we need one little bit of oil. There's 40, and so we're going to need 40 of those to fill it up. So that's what we want them to be able to do. And of course, you're seeing this in fast motion. There's bits in the middle, but just to give you a general idea of the way that that model is mapped, that's where we want to get to at the end. We want them to think of it in terms of 1,000 cubes, how many 25s, or if it's 50 to 1, how many 50s fit into 1,000? There's 20. So for each of those 20, we need 1 cube of oil. So it's 20 mils of oil. If we can get them there, we've got them all the way up to step 6 on the learning progressions. And then we get them to practice. And one of the practice ways is you can use color with water, and then you can test how colorful your water is. So you should be able to see. So if two people have got different colored water, you're like, hey, something's gone off with one of you. And the idea is you get them to practice, compare, justify, and so on. And we use what's called the ICAP model. If you're not familiar with it, it's just a learning model. And it goes like this. At the lowest level, you have passive learning. And that's where you just watch a tutor explain it. And to be honest, when we went around classrooms, that was mostly what was happening. We had tutors trying to explain it on the whiteboard, you know, so not that successful. Active would be follow instructions to mix a fuel sample. That's not bad. Constructive, we'd get them to explain why they needed to add a certain amount of oil to petrol and so on. So that was good stuff, explain it to people. And then interactive, justify what you're doing with other learners, talk about it, experiment, talk about it, and so on. And so we wanted to sort of shift the pedagogy to those better pedagogies where they're really learning that content. Now, this is not formal, but this was just an example of the results that we got from one group, a really difficult group. The intervention was 4 30-minute sessions with 18 learners. There are a whole lot of other things going on here, but before the lessons, nobody could mix petrol and oil mixes, and at the end 14 learners could, and the other 4 were conceptually well on their way, like it wasn't far. So the results of this sort of thing are really good. So that's 4 30-minute lessons spread out, and so suddenly you can bring these students up so that they're not having these difficulties in the workplace. Here's some of the comments from people. So what did you think after the lessons? How are you feeling about those mixes? Kane says, sweet brother, that often makes sense. Should teach the kids that. Dylan says, seeing that petrol as cubes, that's the bit that helped me. Like in your mind, then it's just dividing how many of those out of 1,000. So you can see he's got the idea, he's putting it together. We've given them kind of the conceptual tools to be able. We're nearly there, guys, nearly the end. The process for this is to identify the tasks that cause constant problems, you know, so the paint ones, they're everywhere. In every industry, they have a particular task. In farming, it's working out dry stock grass to feed cows, and usually they're proportional reasoning. Then you analyze why learners make mistakes, and you use the progressions or a framework to map the learning trajectory. You would assess in that process as well. Develop a teaching and learning sequence, and then iterate that teaching and learning sequence. So that teaching and learning sequence, the tutor should be running it and improving it each time, constant improvement, improving what don't we need, what did work, what didn't work, what do we keep, what do we get rid of, until it's perfect. And after, like, you know, you've run 5 different sets of learners through these, that should be pretty darn good, and you should know where the weaknesses are after that. All right, we're at the end. Feel free to jump on the microphone here. You can ask these questions if you like, have a go at it. I thought these would be good questions for you. How are you identifying tasks that your learners are doing at the moment? Are you identifying tasks? Do you know what tasks are causing them difficulties and why? Do you have strategies? And are those strategies being iterated? Like, are you improving over time? And if so, how? Feel free to jump on the microphones or put questions into chat and share your thinking with the rest of the group.
Damon, I have a question. And it's really around AI. Like, so many learners now can literally take a photo of these sort of ratios to get it worked out for them. Yep. I feel like it's a dumbing down of all of us, probably me included, because it's such a easy solution. And you know, it's hard to get the learners to upskill on things like this when they can so easily just Google or use AI for it. Do you have any advice or comments around that?
Oh, I tell you what. So what's emerging in the research is a capability gap, they call it. And this is where your AI can give you an answer that you don't fully understand. And so as the gap between your knowledge and the AI answer progresses, and it's only going to increase over time, you become more and more reliant on the answer of the AI or the software or whatever it is using, and less able to apply critical thinking to that whole thing. So just for example, when calculators came out, you know, the same kind of questions were being asked, you know, why do we have to teach adding if I've got a machine that I can have all the time and do it? And the answer is that you need to be able to justify whether that answer is correct and catch errors as they pop up. And so what you would do is you would allow learners to use the calculator, but then you would ask them to justify that answer. You know, how do you know it's 0.001 and not 0.01? And you would listen to what they say and you would explore whether they have the conceptual understanding of it or not. We're in the same area now, except the capability gap is increasing big time. So the bigger the gap between the learner's understanding or the builder or your mechanic or your doctor and the answer being produced by AI, the bigger the vulnerability to danger, to not catching something. And so it's important that learners can also justify and critique what the AI is telling them. So we have this debate in BCITO, for example, they have a debate. There's an app that works out trigonometry for you. It's fantastic. So it'll work out the angles to cut. But you have to be able to look at that and go, right, is this answer that this software is giving me, is it correct or not? Otherwise, we have an entire generation, which we will have in 10 years, who are reliant on the tools, but with no personal way to judge or justify whether that's correct or not. That's a very, very dangerous place to be. So we have to encourage learners to use the tools. AI, it's here, but also have that conceptual understanding to verify it. So that's the challenge. I don't know how we do that, but that's absolutely the challenge.
Thanks, so Damon. And yeah,
sorry.
I find it interesting as well, and you know, I talk to a lot of learners, is that say around numeracy, they can understand about money because it's so relevant to the everyday, or their speed. You know, if you're traveling 50 k's away, it's going to take you, say, 3/4 of an hour, half an hour, whatever. So essentially they do have that numeracy sort of built into their system when they're working out things like that. But then it's really hard to apply that common logic to something new that they're not sure about.
Yeah, that's right. And you know, as adult learners, because we have expertise in a particular context, we can drag that over into a new context. Like you can use a whole lot of knowledge people have to drag them over to proportional reasoning, unlike children who are developing everything at the same time, pretty much. So adults have all of this extra experience that you can use to learn things. And I think once they see how that can work for them, then they're away. You know, it's often just getting them started on that journey. I think chat, AI is a wonderful learning tool. Like a great thing, like if learners say, hey, teach me how to do this and make sure I understand it. You know, that's a great use of the tool because the tool can give them the answers, but it can also teach them the conceptual stuff to do it. So I think if we do this AI stuff right, we're onto a winner. This is going to be fantastic. But I think if the capability gap grows, yeah, we're in real trouble.
Yeah, thank you.
Any other just general thoughts? What do you think of that general process of identifying tasks? Is that something you've done before?
So, kia ora, Damon. Georgina here. So I'm working at the Open Polytech and with ITE learners who are struggling to get to step 6 on their LNAAT tests and providing some support for them. And it's been interesting seeing the gap, and there's a gap that's coming through where things like decimals, fractions, percentages is a common theme that's coming across the desk. Sorry, I'm ranting. I'm getting to the point. So I guess using the progressions to map where the learners are at, I'm finding that part of the issue is around understanding the questions. So there's a literacy issue as well as a numeracy issue for a lot of learners. But I also work in an online space. So I love the tasks that are in the progressions. There's a challenge in working with learners in an online space.
Yeah.
So do you have any kind of suggestions? Ratios is another one that comes up. So going through that was great for me as revision, because you know, sometimes I'm not clear on this stuff either. So
all of us.
Yeah.
So yes and no. I think interesting. Everything we've looked at today about invisible numbers.
Yep. That's fantastic. Yeah.
Yeah. So it's all of the proportional stuff that's giving learners a hard time on the learning progressions. Gary Sharp did an analysis of the tasks in the LNAAT, the numeracy, and there are a couple of tasks there that like only 2% of people ever passed, and they were the proportional reasoning tasks, which is you know, the adult population has difficulties with those. They're the hard ones. In terms of supporting people to learn once they've done the LNAAT, that's another question. I mean, right now there's Pathways Awadua, which is designed, you know, to dovetail with the LNAAT. That seems to be really successful for some people, and other people it's not. And what we're finding is people with high learner agency, you know, they're highly motivated and they want to go and learn stuff, away they go. But those learners who are a little bit beaten down, they don't believe in themselves, self-efficacy is the word, you know, then they tend to move backwards. And what we find is often they go backwards, like even the skills they have, they tend to lose those skills. Georgina, the answer is I'm not sure. I know Pathways has some success, and I know that people who use AI as a learning tool are having lots of success as well, but it's that barrier to getting them to use it and use it appropriately for learning that seems to be the hard one. I'm sorry, it's not a great answer.
No, that's great. I use Pathways, have used AI to break stuff down when I'm trying to explain something, or learners are just not getting it when we're working one-on-one because Pathways isn't enough and they just need a bit more. AI can break it down if you work closely with it and say, look, we need to understand it, break it down even further. And some success with that too. I was just, any other ideas you have, please flick them my way around.
Sure. I mean, just while you're there, one of the big things in the numeracy research is having mental models. Mental models are like, just for example, we use the Post-its. So we hand out the 2-colored Post-its. So having real things that learners can manipulate improves their conceptual understanding massively. And that's usually what's happened with adult learners who are lower in numeracy skills, is they did that stuff at primary school like we all did, and then that was dropped. And it was all just numbers on paper or on the whiteboard, blah, 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 all the way through. And if you can represent those concepts via equipment, Post-its, rulers, you know, bits of wood, all of that kind of cool stuff we did even in early primary school, that is a huge learning, you know, a big learning curve for a lot of learners on that. So that's one of the things, and that's where chat, you know, AI being a text-based tool is actually not that great, but you can get AI to create images, which can be quite good. So give me an image to help me conceptually understand that can be a great little tool to have in your backpack as well. You know, so
Yep.
Yeah.
No, that's great. Thank you. Appreciate it.
Georgina. I'm just looking at a message here from Lusa. How do you manage learners who meet the program entry requirements, but when they complete their initial assessment and the LNAAT are assessed at a lower step, e.g. step 1? What interventions or support strategies do you recommend in these situations? Well, I think if they're at step 1 or below, then we're looking, if it's reading, then it's that starting points material. The starting points learning progression book, there's 2 starting points learning progression books. They have a little river with stones on them. You can find them at the Ako Aotearoa website. One of those books has assessment tasks in it. That is such a wonderful underutilized resource, but it does require a one-to-one tutor or a tutor who's sitting down working with learners. So that would be my advice for reading. Very difficult on an ongoing course. If it's numeracy, then the step 1 material and the numeracy books is quite good, but also I would go back to school-based stuff. The numeracy project, for example, had really great lessons that started at that low level. So there's plenty of resources out there. Really the bottleneck is around getting somebody who's trained to use them to sit down with those learners. You can do amazing things if you get a well-trained tutor with the right tools, with the right learner at the right time, you know, boom, it's fantastic. So if you can, at step 1, it takes a highly trained tutor who's working with that learner. Really tough to do it like, you know, via online and within the context of a course that's moving through a curriculum. So yeah, sorry. Any other thoughts or comments while you're out there? All right, you've gone quiet out there. Great. All right. Well, what we're going to do is I'll send out these resources, and at the end, I didn't show you, but at the end are a couple of links to some good research articles, and the material that I looked at today. That will all be in an article as well, so you can look at that more if you'd like to. And otherwise, thank you very much for showing up. I hope this was useful, and looking forward to seeing you all again. We have another one, and we might ask another provider to do something in this space at the next one to have a look at what they do around a particular area as well. So these sessions will be really good. Thanks for your participation. Thanks for coming in. Have a wonderful afternoon, and we'll be in touch with all of you. And I'll hang around if you want to say hello or ask any questions as well. So thanks very much, everybody. Bye.